Hi, in this video I'm discussing a question related to momentum. X and Y are two identical spheres and the sphere Y is at rest. Sphere X is moving towards sphere Y at a velocity u1, but the collision is not a head-on collision. That means the center of the X and the center of Y are not along the line that is connecting the direction of velocity. You can see the velocity slightly below the center of the sphere Y. So the collision won't be a head-on collision. So it's a two-dimensional collision. So after collision, the sphere Y is moving along this direction at a velocity v2 and the sphere X is moving along this direction at a velocity v1. The angle between the two velocities after collision is theta. So the question is, if the collision is perfectly elastic, then show that angle theta equal to 90 degree. Okay, so in most of the physics textbooks, this is derived or shown by using a vector diagram and Pythagoras theorem. So by using vector diagram and Pythagoras theorem, you can draw a vector diagram. Then by using some equations, you can easily show that theta 90 degree by using Pythagoras theorem from the vector diagram. So when we do that way, most of my students, they ask, is it possible to do this question or this theory without using vector diagram and Pythagoras theorem? Yes, you can do that, but you need to go through a little more mathematics, mainly simultaneous equations and trigonometry. So I'm going to answer this question without using vector diagram and Pythagoras theorem. I am going to use a general normal method, resolving the vectors horizontally, vertically, and I'm going to use law of conservation of momentum horizontally, vertically. Then I'm going to solve them by using simultaneous equations. Finally, I'm going to show that angle theta equal 90 degree. Okay, so after collision, the angle between the two velocities is given as theta. So the initial direction of velocity is u1, which is shown in horizontal direction. So when I consider this direction, so I can draw a line here like this. So the direction of velocity of v1 with this line, initial direction of velocity of x, I can say this angle theta 1, this angle theta 2. So theta 1 plus theta 2 equal theta. So I need to show that theta 1 plus theta 2 equal to 90 degree. If I show that, that's the final answer. So I'm going to use the law of conservation of momentum in horizontal direction along the initial direction of velocity of x. I'm going to use law of conservation of momentum. I'm going to use along this direction. If I use it, mu1 plus 0 is equal to mv1 cos theta 1 plus mv2 cos theta 2. So I can cancel all the m. So u1 is equal to v1 cos theta 1 plus v2 cos theta 2. I'll take it as first equation. Okay, so use the law of conservation momentum vertical direction. That means perpendicular to the initial direction of velocity of x. I'm going to use it, the law of conservation of momentum. So that will be 0 plus 0, both have no vertical component, is equal to mv2 sine theta 2 minus mv1 sine theta 1. So here also I can divide the whole equation by m and I can bring this to the left side. So I can say v1 sine theta 1 equal to v2 sine theta 2. Consider it as the second equation. Okay, so the collision is perfectly elastic. So I'll write the equation for conservation of total kinetic energy. You know, energy is a scalar quantity, has no direction. So since the collision is perfectly elastic, the initial kinetic energy half mu1 squared, this is 0, so I don't need to write it. This has no kinetic energy because initially it was at rest. So half mu1 squared is equal to half m V1 squared plus half m V2 squared. So here also I can divide the whole equation by half m. So I will get U1 squared equal V1 squared plus V2 squared, third equation. Okay, so by using these three equations, I am going to show that theta equal 90 degree. Okay, so what should I do next? I want to eliminate. So I need to get finally a relationship between only theta 1 and theta 2. So I need to eliminate V1, V2 and U1. I need to eliminate by using all these three equations. That is mathematics, not physics, right? So how am I going to eliminate it? So here U1 is equal to V1 cos theta 1 plus V2 cos theta 2. I'm going to substitute that instead of U1 squared here. So I can use the equation 1 and 1 in equation 3 if I write it again. So I can say like this. I'll use black ink for that. U1 square. Instead of U1 square, I can write V1 cos theta 1 plus V2 cos theta 2. So I can write V1 cos theta 1 plus V2 cos theta 2 all things squared. Is it? That is the U1 squared is equal to V1 squared plus V2 squared. So expand this one. V1 squared cos squared theta 1 plus V2 squared cos squared theta 2 plus 2 V1 V2 cos theta 1 cos theta 2 equal V1 squared plus V2 squared. Okay, we know that cos square theta equal 1 minus sine square theta. We know that sine square theta plus cos square theta equal 1. We know that in trigonometry. So sine square theta plus cos square theta equal 1. So cos square theta equal 1 minus sine square theta, right? I'm going to use that one now. Okay, so this one V1 squared 1 minus sine square theta 1 plus V2 squared 1 minus sine square theta 2 plus 2V1 V2 cos theta 1 cos theta 2. I'll write that the same way. 2V1 V2 cos theta 1 cos theta 2 equal V1 squared plus V2 squared. Okay, now look at here. If I multiply inside here, there will be V1 squared minus V1 squared sine squared theta 1. You can solve this one. V1 squared minus V1 squared sine squared theta 1. So V1 squared here will get cancelled with V1 squared on the right side of the equal sign. So this V1 squared and this V1 squared will get cancelled. Same way V2 squared, if it goes inside, V2 squared minus V2 squared sine squared theta 2 will be there. So this V2 squared, that is V2 squared into 1 is V2 squared. That V2 squared and this V2 squared will get cancelled. So I'm going to get this one minus V1 squared sine squared theta 1 minus V2 squared sine squared theta 2 plus 2V1 V2 cos theta 1 cos theta 2 equal to 0. Okay, so now what I'm going to do, write this one. Okay, so now you know that this one here, if you want I can take this to the right side. So I can rewrite this one 2V1 V2 cos theta 1 cos theta 2 equal V1 squared sine squared theta 1 plus V2 squared sine squared theta 2. Okay, so you can see the equation 2 now. In this equation 2, it says that V1 sine squared theta 1 equal V2 sine theta 2. V1 sine theta 1 equal V2 sine theta 2. So instead of this V1 squared sine squared theta 1, V1 squared sine squared theta 1, I can substitute V2 squared sine squared theta 2. I can replace this one. V1 sine theta 1 equal V2 sine theta 2. So if I square this, V1 squared sine squared theta 1 equal V2 squared sine squared theta 2. So instead of this V1 squared sine squared theta 1, I can substitute V2 squared sine squared theta 2. So if I substitute that one, it will become V2 squared sine squared theta 2 plus V2 squared sine squared theta 2. So if I add those two, it will become 2 V2 squared sine squared theta 2. Anyway, I'll show that one again. I'll show that V1, V2 cos theta 1 cos theta 2 equal, instead of V1 squared sine squared theta 1, I'm going to substitute V2 squared sine squared theta 2 plus V2 squared sine squared theta 2. Right. So now what I'm going to get here, that will become V1, V2 cos theta 1 cos theta 2 equal. So here these two, here you added V2 squared sine squared theta 2 plus V2 squared sine squared theta 2 will be 2 V2 squared sine squared theta 2. That 2 and these 2 got cancelled. You will get V2 squared sine squared theta 2. Okay, so still I need to eliminate V1, V2. How can I eliminate it? Instead of this V1, I can substitute V2 sine theta 2 over sine theta 1. Instead of this V1, I can make the V1 subject. If I make the V1 subject, instead of the V1, I can write V2 sine theta 2 divided by sine theta 1 equal V1. Right? So I'm going to substitute that V1 here. So I can substitute V2 sine theta 2 over sine theta 1 into this V2 cos theta 1 cos theta 2. Only thing I am doing, instead of V1, I am substituting V2 sine theta 2 over sine theta 1. So V2 sine theta 2 over sine theta 1 is V1. This V2 is there. Cos theta 1, cos theta 1, cos theta 2, cos theta 2 equal, again, V2 squared sine squared theta 2. Right. Now you can see that sine theta 2, here sine squared theta 2. I can divide the whole equation by sine theta 2. So this sine theta 2 will get cancelled. V2 into V2 is V2 squared. Here V2 squared is there. So V2 squared also will get cancelled. V2 into V2 is V2 squared. That V2 squared and this V2 squared will get cancelled. I can divide the whole equation again by sine theta 2. So this sine theta 2 will get cancelled. This sine squared theta 2 will become sine theta 2. Then what I'm going to do, I'm going to cross multiply sine theta 1. So you will get an equation here like this. Sine theta 2 got cancelled. V2, V2, V squared, that also got cancelled. So cos theta 1, cos theta 2, cos theta 1, cos theta 2, because this sine theta got cancelled, I divide the whole equation by sine theta 2. So here the sine theta 2 will remain. Then I'm going to multiply the whole equation by sine theta 1. So this also will get cancelled, or I can say this will be cross multiplied to this one. So it will become sine theta 2 into sine theta 1. So equal to sine theta 1 sine theta 2. That means cos theta 1 cos theta 2 minus sine theta 1 sine theta 2 equal to 0. So you know that cos A cos B minus sin A sin B equal to cos A plus B. So this will be cos theta 1 plus theta 2 equal to 0. So solve this equation. So you know, take inverse cos, that is theta 1 plus theta 2 cos inverse 0, 90 degree. That is theta 1 plus theta 2 equal to theta. So therefore theta equal 90 degree. Anyway, you can do by using Pythagoras theorem and vector diagram easily without having a lot of maths. But here, if you try to answer this question without using Pythagoras theorem and vector diagram, you need to have a lot of mathematics, trigonometry, and simultaneous equations. Anyway, but you can answer. Normally, students they ask, is it possible to answer without vector diagram and Pythagoras theorem? Yes, you can answer. So that's what I did this question without Pythagoras theorem and vector diagram. I hope you understood. Yeah.